So, welcome to our project. Our project is on brain stroke prediction using machine learning and then deploying it in FLASK. So, we thank our supervisor, Dr. A. Prakash, for guiding us throughout this project. Let's move on. And today's our agenda would be about the abstract and the introduction, the text testing, and all this. And the abstract, initially, the stroke occurs when a blood vessel is either blocked by clot or burst, in the medical terms. So with this issue, our work would be like we would collect the data set of various patients which contains various medical factors, and we would be working on the Jupyter IDE to work on this data set, and we'll be using some machine learning algorithms and predict whether the person is suffering from stroke or not. For this, we had some initial steps like pre-processing, and then go into the feature scaling step, which is used to normalize the range of independent variables, and later on use the libraries of the algorithms of logistic decision and KNN, and then at the end find the best accuracy among the three which we are implementing in this, and hope this helps the patients in the real world for early prediction of stroke. Our aim is simply to predict the stroke using multiple machine learning algorithms and then deploy it at using FLASK with a good accuracy algorithm. Introduction, it is pretty everything about the basics of machine learning which we are working on it, and as you know, the goal of the study is to use machine learning to forecast the occurrence of a brain stroke, and among the five various algorithms, the important components of the approaches utilized and the results produced are those. And the model's weakness is that it is trained on textual data rather than real-time brain pictures. We demonstrate five machine learning classification methods in action, but we had to drop out a couple of two due to inefficiency of those algorithms. Literature review, we have gone through more than a couple of papers wherein we found some backlapses in those. So the first one was completely on the decision tree with the C4.5 algorithm, which is an advanced algorithm under decision tree. But here the backdrop was that the data set taken for this work had a very smaller input. And the same goes with the other papers with some or the other backdrops. And these are designed the collection of data. This is a collection of our data, and then the data pre-processing, the things that we undergo is feature extraction, mixing values, and the label and coding, and then the more algorithms, three of them: logistic, decision, and KNN. This is a random forest which we aren't going ahead as it is very inefficient. And finally, for the result, we would be using HTML, CSS, and FLASK to deploy it with the localhost. This is how the architecture diagram looks like: the data flow, VEER, and the unit testing which we have tested a part of our code. Integration, where we have integrated the web pages like HTML, CSS to the FLASK, and the model, machine learning model, also to the FLASK. The functional testing, wherever we have used the functions in our FLASK application, have been tested. This is how the input output looks like. So I would conclude that this machine learning model on three algorithms would deploy the we have deployed it, and we have got one best, that is decision tree, and we have integrated with the FLASK framework. These are the references. And let's move on to the project implementation. Hope that gives you a good idea. So these are the main model creation implementation in Jupyter Notebook. The first one we have we had to install matplotlib, and we had imported that. We had to import pandas, and the initial steps are just to clean the data, take out the unnecessary things so that it can be trained properly with the algorithms. So this is how it looks like, and detail here. It's all about the data cleaning and data rectifying, and later we split it into training and testing, and then we come and we normalize it, the data, and then we come to the algorithms part, wherein we implement, we give the libraries of those algorithms, and later uh, we would be saving it to our local machine. Like we had done this with logistic, and we can also do it with each of the algorithms. And before that, we had also saved the scalar object, which is nothing but the data pre-processing and everything that got saved here. So you can check it in the file location that I had given. So let's move on to the main app part. So this is everything. This is all about Flask, or the framework which we have designed. Here also we'll be using some of the libraries like Pickle, Flask, and once you run this, I'm running it again, you get this local host here. So here basically the whatever I had showed you here about saving this file, this and the algorithm one, I will be integrating it here at two places, and also I would be adding HTML and CSS, HTML and CSS pages. So that's how all this code has been done. And when I click this, the local host opens. Sorry, now it has opened. So let's give, so here gender, one is for male, so 1. Let me put 21, then let's put hypertension 1, heart disease 0 and no 0. Work type, let's put 2, let's put 1. Average glucose level, let me put around 128. 1. Let me put 34. Let me put 0. Alright. See, now you get the prediction whether it's diagnosed or not. So let us go with an diagnosed input. So let me take from this Excel, yeah. So it's 0. So for male, let us put 1. So age, it is 67. Then let me put 0, 1. For yes, it is 1. For private, it is 2. And for urban, it is 1. And the average glucose level 69. BMI is 36.6. Formally smooth, let us put 1, and let's take out this value. So we have taken we're testing with an input of stroke diagnosed 1. So we have been diagnosed with stroke, and even in the database it says it is an input of having a stroke to that kind of inputs. So that's it. Thank you. Hope it is good enough. If there are any inputs, we would have any changes later on. Thank you. Thank you all.